Let's find the derivative of the following function. So f prime of x, that's our notation for derivative, of the function f of x is equal to 10 all over x. Now recall our definition of the derivative, the limit as h approaches 0 of the function f of x plus h minus f of x all over h. So our first challenge is to evaluate the function f of x plus h, and then from that we're going to subtract the function itself all over h. Once we've done that, we'll take the limit as h goes to 0. So I've written that out already here. Notice that we've plugged in x plus h into our function. Wherever there's an x, we obtain x plus h minus 10 over x, in this case all over h, taking the limit thereof. Now what we need to do is take the LCD of our denominators. In this particular case, we can multiply top and bottom of our rational expression by the LCD x times x plus h all over 1. In some cases, it's good to write that. What we do in the numerator, we must also do in the denominator as well. So distributing, here's what we obtain. The limit as h approaches 0 of the following. In this case, the x plus h's cancel out. We get a 10x minus, here the x's will cancel out, 10 times x plus h, and that will all be over h times x plus h. Distributing in the top here, we obtain the following. Limit as h approaches 0 of 10x minus 10h all over h times x plus h. Conveniently here, the 10x's cancel out for us, so we can look at the following problem. The limit as h approaches 0 of negative 10 times h all over h times x plus h. All right? Keep with me here. We're almost through here. The h's cancel out. We get the limit as h approaches 0 of a negative 10 all over x times x plus h. Now finally we can evaluate the limit as h goes to 0. So in doing so, that term disappears basically. So we get a negative 10 all over x times x, which is simply x squared. So finally, exhaustive practice here, but we found that the derivative of this particular function is negative 10 all over x squared.